Hi, it's Dr. Alan Sands, and let's talk about specific heat capacity. In this video, you are going to learn what is heat capacity and specific heat capacity, formula on calculating them, and I'm going to give you some examples too. I'm also going to give you some ideas on thermal equilibrium. Unlike other videos on YouTube, this video is going to explain step by step instead of just throwing a bunch of formula to you. This video is carefully structured and designed with colorful schemes and pictures, so that you will not lose interest. Are you ready? Let's go, go, go! Have you ever noticed why it takes much longer to boil a larger amount of water? It's all because of heat capacity. So, what is heat capacity? Heat capacity of a body is the energy transferred by heating needed to raise the temperature of the body by 1 degree Celsius. So let's have a look at the cup here. Inside the cup, there are some substances. It takes 1000 joules to heat it up for 1 degree Celsius. Therefore, it has a heat capacity of 1000 joules per degree Celsius. It's useful to find heat capacity so you can easily find out how much energy and how long it takes to raise the temperature of a substance by other amount of temperatures. However, heat capacity can't help us find out the devil energy waster. That's because heat capacity is not fair. Heat capacity includes mass. If you have a higher mass, it takes longer for you to raise the temperature by 1 degree Celsius. Therefore, to measure how much energy is needed to raise the temperature of 1 kg of the substance by 1 degree Celsius, we have to consider specific heat capacity. Given the same mass and the same temperature to be raised, who is the devil energy waster which makes people take a lot of energy to heat up? Specific heat capacity is the energy transferred by heating needed to raise the temperature of 1 kg of the substance by 1 degree Celsius. Sounds complicated? Let's have a look at the following example. Water has a specific heat capacity of 4200 joules per kg per degree Celsius, and aluminium has a specific heat capacity of 900 joules per kg per degree Celsius. What can we deduce after we have these data? To raise 1 kg of water by 1 degree Celsius, it takes 4200 joules. To raise 1 kg of aluminium by 1 degree Celsius, it takes 900 joules, and therefore it takes much more energy for us to raise the temperature of water, given the same mass, given the same temperature to be raised. Now I'm going to tell you the formula for specific heat capacity and heat capacity. But before we get started, there are some symbols to remember. Q is the energy transferred, M is the mass, C is the specific heat capacity. Note that specific heat capacity has a symbol of a smaller letter C instead of a larger letter C. So larger letter C is actually standing for heat capacity, while smaller letter C stands for specific heat capacity. Just think about it like this. If you are more specific, you are more careful, and if you are more careful, it's kind of more smaller details you will also notice. So make sure that specific heat capacity is the smaller symbol, which is the lower case. And also delta T is the change in temperature, which is final temperature minus the initial temperature. Sorry that this should be minus instead of equal. In fact, for heat capacity, as is the energy transferred by heating needed to raise the temperature of the body by 1 degree Celsius, we can treat it as energy needed per 1 degree Celsius. Therefore, we can have a formula of getting heat capacity. It's energy divided by the change in temperature. On the contrary, the specific heat capacity is more specific. It is the energy transferred by heating needed to raise the temperature of 1 kg of the substance by 1 degree Celsius. Therefore, the specific heat capacity will seem like energy needed per 1 kg per 1 degree Celsius. Therefore, we can find out the formula being specific heat capacity equals to the energy divided by the change in temperature divided by the mass. Keep in mind for some of the units that you have to bear in mind. The unit for energy is joule, the unit of temperature is degrees Celsius, the unit of mass is kilogram, and therefore the formula of heat capacity and specific heat capacity can be found out. For example, The unit of heat capacity, because it's joule divided by degrees, so we just directly say joule divided by degrees. We can have this as a unit, but a more formal way is to write like this, because it's the same that we write it's the power of -1. For specific heat capacity, we can actually say as the Q is the energy needed. So we have joule and then per mass per delta T. So we actually have a formula of this. But as we all know, we would like to make it much more readable by people, and people usually prefer writing kg first before writing degrees Celsius. Let's have a look at this example. In this example, you will understand how to give the unit of specific heat capacity, and also how to find out the specific heat capacity given the mass, energy, and the change in temperature. The answer is that we just directly substitute the numbers into the specific heat capacity formula, giving us 3,770 joule per kg per degree Celsius. Now there's a much more difficult problem for us to solve. Dr. Allen wants to make some hotspot and place 20 fish balls, each of 0.07 kg, into the 2 kg of hot water at 10 degrees Celsius. Take the specific heat capacity of fishball 2,300 joule per kg per degree Celsius, and take the specific heat capacity of water 4,200 joule per kg per degree Celsius. Find the energy needed to raise the temperature of the mixture to 100 degrees Celsius. Pause the video and think about it. The hint is that the energy absorbed is equal to the energy gained, which is a thermal equilibrium. Don't worry that you don't know this yet, because I will talk about it later. Try to solve the problem first. In fact, we can let Tf be the temperature after the fish balls are placed into the hot water, after it has been placed into the hot water. So when the cooler fish balls are placed into the hot water, as mentioned in the previous video, there will be heat transfer. When there's heat transfer, the heat will flow from the hotter object to the cooler object. The energy absorbed by the fish balls is equal to the energy released by water. This is a basic idea on thermal equilibrium. The energy absorbed and energy released can both be calculated by specific heat capacity. Finally, the energy needed will be mass of water times the specific heat capacity of water times the change in temperature plus the mass of fish balls times the specific heat capacity of fish balls times the change in temperature. This is much more difficult because we are finding energy needed to raise the mixture instead of a substance. Therefore, you have to think of the energy needed separately. I won't give the answers to you, so you can have a chance to calculate this question and solve the problem. Put your answer in the comments below, and I will get back to you later so that you can check whether your answers are correct or not. Please make sure you subscribe, comment, like, and share. If you subscribe, you will be a super magician and wizard in terms of science. You can literally be the king of science. If you have any questions related to this video, comments down below. I will reply to you as soon as possible. Thanks for watching.